All right, so this section is solving systems graphically. All right, so for these ones, we are just going to be graphing the two equations, and then honestly, wherever they intersect is the solution. So we kind of saw on these that our solution is always a point, and so this will really help us visualize like what is that point, okay? So just quick review on graphing. We always kind of want to graph into y equals mx plus b, right? And so for this one, the slope is 1/2, and the b is the y-intercept is 3. So I always say that the b, you can think that that stands for the beginning. That's where we begin graphing. And so I'm going to go to the y-intercept of 3. Make sure you do that as a y-intercept, not an x-intercept, and you put a dot there. Then the m, I kind of think of that as the movement. If you want to think that that's what the m stands for, is movement. And so that is rise over run, okay, as up 1 over 2. And so from the beginning, I'm going to go up 1 over 2, up 1 over 2 again. And there I have my line. I always kind of double check on these. If it's a positive slope, which this one's a positive slope, it should be increasing as I read it left to right. And so we can see that this one is in fact increasing as I read it left to right. So that's good. Okay, so then the other one, my m, I'm actually going to write my m as 4 over 1. So anytime your slope is not a fraction, just put it over 1. And my beginning will be -4. So we're going to go up 4 over 1, draw another point. You can do it again, up 4 over 1, draw another point, and we actually see the intersection point right there. So the intersection point is going to be our answer to the question. So it looks like on this one, it is, remember that's going to be an x comma y. So that's going to be here 2 comma 4, representing that point right there. That's it. All right, so let's try it again here with another y equals mx plus b. So next one here, I get my m is -5 over 2. So I have my first negative slope today. And so I'm going to make sure that this is decreasing as I read it left to right. We have a b value of 2 here. So I'll draw my b getting at 2 with a y-intercept of 2. And I'm going to go down 5 over 2. I mean, my next point is right there. I don't really have any room for any other points, so I'll go ahead and draw my line. We do see that this blue line is decreasing as we read the graph left to right, which is good because that's what the negative slope is all about, right? Okay, so then the other one here, we have a slope of 1/2, so that's another positive slope, and then a b value of -4. All right, so my b getting at -4 is down here. The y-intercept at -4. All right, and then we're going to do our slope is up 1 over 2. So we can draw a couple points there, draw a nice line. We see a clear intersection point there. And x comma y, we can do this as 2 comma -3. All right. Whoa. Oh. All right, so not too bad, right? Okay, we're gonna get a little trickier on our next ones here, so stick with me. So you can see on numbers 3 and 4 now, they don't put it in y equals mx plus b. So what you're going to do kind of first for these ones is just get them into y equals mx plus b. So really what we're doing is isolating y, okay? So on number 3, I'm going to subtract 6x from each side. I'm actually going to kind of do that above this just so I don't have to rewrite it. And now I'm gonna write what happens over here. So I subtract 6x from both sides. And I get y equals negative 6x minus 2. That is now in y equals mx plus b, right? And so my m will be negative 6 over 1. My b will be negative 2. So I'll go ahead and draw my beginning at negative 2. Remember, it's a y-intercept of negative 2. And then my slope is negative 6 over 1. So if I went down 6 and over 1, that would be over here. There's no really space for that. So I can go kind of backwards here. So I'm going to go up 6 and then actually to the left 1. So it's actually right here, okay? What I kind of, that's kind of tricky on that one. So what I always just make sure is that after I'm done, okay, if it's a negative slope here, so is my line decreasing as I read it left to right? Yes, it is. So that's what I always double check there after I draw it, because sometimes it's a little tricky if you have to kind of go backwards like that. So just verify if it's a positive slope, it should be increasing as you read it left to right. And if it's a negative slope, it should be decreasing as you read it left to right. And you do read the graph left to right, just like you read a book left to right, right? You read a sentence left to right, you read these left to right. Okay, so then my other line, get another color here. Okay, so I'm going to subtract x from both sides. So I get y equals negative x plus 3. That is isolating y. Now my m here is kind of a tricky one. I have no number in front there of the x, but I do have a negative there. So it's really negative 1x. And so my slope is going to be negative 1 over 1. And my b will be 3. That one's not too tricky. All right, so I draw my y-intercept there. And then I go down 1 over 1, down 1 over 1, down 1 over 1. So there's my line right there. I do see we have an intersection point aquí, right here. So that's my solution. So what are the coordinates there? I have negative 1 comma positive 4. Okay, let's continue. Number 4. Otra vez. It's not in the y equals mx plus b form, so we need to get it in the y equals mx plus b form. So I'm going to subtract 5x from each side here. Oops, from each side of the equal sign. So I get negative 3y equals negative 5x minus 12. Now in this case, I have an extra step here because y is not yet isolated. I got to divide everything by negative 3. So divide by negative 3, divide by negative 3, divide by negative 3. Notice that I divided all the terms by negative 3. You have to do that. For adding or subtracting, it's like terms only, but for multiplying and dividing, it's really every term. So this is going to tell me y equals, and then we know a negative divided by a negative is a positive. So I'm going to write this as 5 over 3x plus 4. I'm not going to do a decimal for 5 over 3 because since that's the slope anyway, it's kind of better for us to think of it as a fraction as the rise over run, okay? So I have my m as 5 over 3 here. I have my b as 4. So let's go ahead and draw that. If I go up 5/3, I'm off the chart. So I have to go down and left. So down 5 to the left 3 would be right there. So that is our line. Once again, I had to go backwards on that one. So just kind of make sure if we have a positive slope, it's increasing from left to right. Yes, it is. All right, so let's do the other line now. So I'm gonna subtract the 5x over to the other side as my first step. And I'll put this down here. So we have negative 3y equals negative 5x minus 3. I'm going to divide everything by negative 3. That gives me y equals 5/3x plus 1. So I got my slope at 5/3, my y-intercept at 1. It looks like, again, I can't really go up 5/3, so I'm going to go down 5 and to the left 3. Okay, now the solution is where they intersect. So where do these two intersect? Trick question, right? They do not intersect. So what do you think that means when they do not intersect? What was it? No. We're going to see that on our next problem, what infinitely many looks like, actually. So what's the other option, the other kind of special case we have? No solution, yes. When they never intersect, that's going to be a no solution. If you want to write on here that these lines are parallel, that's probably a good thing for you to know. But ultimately, the answer here is no solution. These lines are parallel, okay? They're never going to intersect. So why were they parallel? Why was there no solution here? Well, I think the key indicator to me, we saw that they look back at their slopes. Do you see that our two lines ended up having, when we got them into y equals mx plus b, they had the same slope, but they had different y-intercepts, correct? So that's what's going to cause the parallel lines. That's what's going to cause the no solution, okay? Same slope, different y-intercepts. Okay, let's go on to our next one here. Number 5. Yeah. All right, so for number 5, neither one of these are in y equals mx plus b, right? Even the first one is like in x is isolated, but I don't like that. I want to get the y isolated, correct? So for the first one, I'm actually going to keep the y on the right-hand side. You are allowed to do that. I'm just going to add the 2 over to the other side. And I'm just going to say y equals x plus 2. So I'm going to rearrange kind of the way I wrote it. Like when I was solving it, I kept the y on the right side and then moved everything to the left. But then when I rewrote it, I just wrote the y first. It's like if I say x, y equals 5 or 5 equals y, that means the same thing, right? Okay, so then let's do the other one. So for this one, I'm going to kind of do a similar thing here. I'm going to subtract the 3x over here. But when I rewrite it, I'm going to put the y on the left-hand side. So I'm going to say negative 3y equals negative, negative 3x minus 6. Then I'm going to divide everything by -3. And I get y equals, and then -3 divided by -3 is just 1x. So I'm just going to write x plus 2. Oh, I didn't draw my first line. So my first line, m equals 1 and b equals 2, right? Okay. So then my other line, m equals 1 and b equals 2. So there we go. So then my question would be to you guys here, where do these two lines intersect? Well, they're always intersecting, correct? They're intersecting at every single point along the line. So then this one is the one that we would say infinitely many solutions, because they are literally always intersecting, okay? Why are they always intersecting? Well, once we got them into y equals mx plus b, they were like literally the same line, correct? So that's what it's going to look like if it's infinitely many solutions. When you get into y equals mx plus b, it's really the same line, okay? Okay, got a little meme for this here that I created actually. So let me share that to you real quick before we move on. All right. So when you have infinitely many solutions, there you go. It's like the Spider-Man meme, yeah? Y equals 6x minus 15. And then we got the other one. If we rearrange that, if we add the 18x over and then divide by 3, they realize that they're actually the same line. And so that's why they have infinitely many solutions. Mr. Berry creating memes to help teach math. All right. All right, cool. I don't think we need to do number 6. Let's skip that one. Let's come down here and do the word problem. Sounds good. And I want to give you guys time to work on that that quiz, that group quiz if you didn't finish it. Okay, so you finally move out of your parents' house and into a new apartment. You're not able to survive without TV, so you make some calls to find the best offer. DirecTV offers their service for $5 a month plus $2 for every movie ordered. On the other hand, Dish has a flat fee of $13 a month with unlimited movies. Solve the system of equations graphically, okay? So here's how I would write this system of equations, okay? So for DirecTV, it's $2 for every movie. So I'm going to say that y equals here 2x. So if I order like 3 movies, it's going to be $6, right? If I order 10 movies, that's going to be $20. So since I have to pay that $2 every time I watch a movie, that's what's going to be multiplied by x. And then the 5 is, that's just what I have to pay no matter what, right? I just have to pay $5 at the beginning of the month plus $2 for every movie. Dish, on the other hand, it's $0 per movie, and I just have to pay $13 a month. So it's not 13x, because it's not $13 per movie. It's just 13. It actually technically would be like 0x plus 13, because the movies are free. So we can definitely graph this. All right. So we're going to have 2x plus 5. I got my y-intercept of 5 there. I'm going to go up 2 over 1, up 2 over 1. There we go. It doesn't really make sense for me to watch negative movies, so I'm just going to do it to the right. And then y equals 13, if I think we did this way back last semester. If it's just y equals a number, that's always just a horizontal line. So we do see we have an intersection point here. We have a solution. And that solution would be 4, 13. So explain what the solution means in terms of the TV service. Well, if we really kind of think about it, the solution is where the two lines intersect, correct? So that's kind of the point at which the two plans are the same. And so what I'm going to say there is, if I watch 4 movies, the plans cost the same. And what do they both cost? I'll go ahead and put that in parentheses. They both cost me $13. So if someone was to ask you which one of these plans are cheaper, I would have to answer by saying, well, it depends on how many movies you're going to watch, right? If I'm going to watch less than 4 movies, I would say that the red line is lower, that the, what is that? DirecTV is cheaper, correct? But if I'm going to watch more than 4 movies in a month, I would say that the blue line, that Dish is cheaper, right? And if I'm going to watch exactly 4 movies a month, then I would say they cost the exact same. All right. All right. So then last question here, when 9 movies are ordered, what is the difference in price between the two companies? So I can't really see where 9 movies is on my red line. So I'm actually just going to plug it into my equation here. Since we know X now represents the number of movies, right? So we know then that the red line, that the DirecTV would cost $23. The blue line, the Dish, is going to be a lot easier. If I watch 9 movies, how much is Dish going to cost me? 13, because it's always 13. Yeah. So what's the difference? $10. Oops, $10. All right, cool.